Hello everyone. So for today's topic, I actually wanted to discuss more about how um, databases, especially this last time I was not able to actually demo how Postgres handles different queries and how you can use it. And similarly, in the meanwhile, I also not discovered, or you can say I actually read about Redis. I have used Redis for a while, for quite a while now in different projects of mine, but I never compared it with Postgres or a database and never had the moment to actually check it, how it actually works, or how much fast it is as compared to different databases. So let's try to actually look into it today and see what different possibilities we can have. Okay. So here is our. So actually, before we even try to go it into something like thinking about why even something like Redis might be fast or quick as compared to databases. So the idea is, if you have already studied about computer architecture, we know that each of our programs live in the processor, computer processor. That is where instructions are actually executed. Okay, so when our instructions are executed and we have input output operations IO, which we call as, we have to take stuff from the disk or from memory or from cache, whatever you can call it. Operating system guys know more about this, or maybe I will actually someday discuss more details about this. But these are actually the L1, L2, and L3 caches, which are most close to the processor. Okay, so if there is something inside L1, L2, and L3, since L1 is in comparison of the distance is the nearest one as compared to the processor, so it's gonna take quite lesser time to get items from here, probably in nanoseconds, 1 nanosecond. Similarly, it will be a little bit more in L2 cache or a little bit more in L3 cache. And similarly, when we go to RAM, it would go into values of like 100 nanoseconds maybe, or probably 200 nanoseconds, let's just say. While if we go to the STD and SPD, we already know that it now takes milliseconds, okay, not um, maybe microseconds in the best optimizations case. So that is a difference, high level difference of how something like Redis, because Redis is actually an in-memory store, remember, while databases, our data is actually stored in HDD and SSD. And you would ask, if I have an in-memory store, why do I even need to have a database? The answer is, of course, it comes with a price. You cannot, we can see we have 64 gigabytes of RAM. It is quite pricey, but still, yeah, it is quite pricey as compared to the hard disk or SSD. You can just imagine their pricing ratio, and the pricing comes with the cost actually comes with how much performant it is. That is why. But actually, instead of just babbling about it here, I think I will actually share all the scripts or the commands I actually used to create the database instances, both for Redis and Docker. I did not want to waste my time doing that here. So let's just try to. So this is our table. Okay, students. It has an ID, which is an integer, a G value, so first name, last name, and date of birth. Okay, we have a primary key because by default Postgres has a primary key, and it's a B tree. Remember, B trees, not binary. So it's student primary key. Now it's time to actually run some little commands. Okay. So yeah, let's see. Okay, so our query planner has returned and we have processed around about 85, 8,059,599,357. So these are almost 8.5 million rows, quite large. And the time it took is 3244. So it took actually 3,244 milliseconds, almost 3.2 seconds. Actually, when I ran it before. And yeah, one more thing, it's a sequential scan. Remember, it's a sequential scan because there is no index on nor the ID and the G value. Okay, and remember the time, it is taking 3244 milliseconds, 3 seconds almost. Now if we try to run a similar query in Redis, so this is actually the command read z range by score, grade index. This syntax actually means that the value 80 and 95 are excluded, okay? Because we are looking into values where it is greater than 80 and below 95. That is why. And this is actually command. These are commands are actually for sorted sets. So sorted sets are in the simplest form. If I try to explain it, these are similar to priority queue. They might be priority queue. Uh, Sorry for that. I do not exactly remember, but they are similar to priority queue. Queue where first in, first out concept, And what happens is in the queue, if you store items priority wise, where priority we give a specific value to the given item you're storing, that defines its priority. That is what sorted sets are. Okay, so here we are storing items along with their based on the value of G they have. Okay, let's just try it. Okay, that was quite fast. I think I should actually let me just reset the logs first because I don't want to um, show the last values. And yeah, we are not going to run for limit. We are going to run for simple weather scores. Okay, taking some time. Nice. So it took some time, and we have to get. Yeah. So reading this can be a bit challenging, but I'll try to explain it. I just learned about it now. So this was the command we ran to reset the logs. And here we have a value. So this value is actually in microseconds. We have 84,000, no, it's 841,944 microseconds. Okay, so if my brain works fine, I think it's about 8.4 millisecond, I believe. Yeah, because we have eight. Yeah, I don't want to actually waste my time here, but yeah, I probably might be wrong here. Let me just take help of Claude in microseconds. See the benefit of using Claude and ChatGPT. You cannot even calculate basic things. So it's actually microseconds. It's almost about 0.842 seconds, not even a complete second. It's still fast as compared to Postgres. And remember, here we have 8 million rows as compared to Postgres because I ran out of memory. So it is actually getting these values from 10 million rows, while Redis is actually having 8.5 million rows. But it's still fast as compared to them. Now let's try with the limit 1000. Yeah, quite fast because this cache. I think I had discussed in the last video that when you try, there is a buffer pool by managed by the database, Postgres or any other MySQL server, whatever. It's a buffer pool. So I ran these commands before, and when the ran before they had like 73, probably 730 milliseconds. That was quite long, 73 seconds. But here now we have 9.249 milliseconds. It's honestly quite better as compared to what we saw last time. Okay. Um, Now let's try to run a similar query using the limit here. Quite fast. Let's see the log. Okay, with the scores, and this time we have yo. Okay, so we have the value 2,970 microseconds. It's now in below 2 millisecond. I know you might say that the difference is decreasing as compared to 9 millisecond. It's 2 millisecond, but it's still fast. I already explained that there's something called as disk um, cache operating. There are multiple levels actually. When you bring stuff from the disk, your database, not only the operating system has its own cache, and the database manages its own cache, which is called as buffer pool, that it actually keeps the items which it already actually retrieved. So you can say it is trying to actually access them from RAM, but it's still Redis is fast as compared to it. And furthermore, yeah, I think if we now try to, because the difference is going to be a lot less, create index g index on, I'm sorry if I do not remember even basic commands because so create index here and yeah, that is the command grades, students, see, students g. Okay, I can only hope that it works. So now I'm creating the index and let's just try to, I will actually exclude the value ID since it's not indexed. And now let's see this one. Okay. And so yes, you can see, I think the light went out, but anyway, as you can see, we have execution of roundabout. So we have bitmap not needed. So we have and bitmap index scan. I will actually someday explain what is bitmap, but you can see the execution time is 1997 millisecond. It's still fast as compared to when we tried to run um, the simple scan. Now just let's apply 1000 limit on it. Quite fast, 2 milliseconds. It's now comparable to how Redis is returning those results to us. But that doesn't mean that Redis is not useful. As I said, in many scenarios when we are fetching items, of course, this is on the same instance, and when you are working across the network, of course, Redis is going to be more efficient because it's taking items from memory, not from disk. So it's definitely, and your each query might not always be buffer pooled or cached by the operating system. Okay, so that actually takes a lot of trouble or actually burden from you. So yeah, that's probably it, I think, and I hope you learned something new today as well. I just wanted to practically demonstrate it both for Postgres and Redis, and that's it. Have a good day.